Welcome to the Things Conference 2020. Welcome to the world of billions of devices being connected all around the world. Pushing Industry 4.0 with 5G. Oh no. 0G. Or G0. G what? How much G? What's up, G? G... What is this? Error. 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 You are here at the no-nonsense Internet of Things conference that brings you the things just like they are. Blood, sweat, and tears. Finding the right partners. Embracing open standards and hard work. We dive deeper into the technology and deeper into the business cases. The accumulation of all the screw-ups led to the maturity LoRaWAN has today. Success in the Internet of Things is only for those who have seen the graveyard of failed proof of concepts. Today, LoRaWAN has proven to be a solid technology, with a solid return on investment across many verticals. You are at the right place at the right time because LoRaWAN is here to scale. The best way to predict the future is to create it. So let's start replicating the successes and build that world of billions of connected devices. Let's get started.
So, welcome everybody.
Wow, you made it all the way back to Amsterdam. Welcome.
It's a huge honor to have all the visitors, all the partners that have come to Amsterdam and look at this huge crowd. This is the biggest side project we currently have.
It is escalated completely.
Yeah, this got a bit out of hand 2 years ago. We came up with this idea because we had all these thousands of meetups around the world. Let's just do one big conference. We started with 800 people already in 2018, and now there's around 1,500 people. So again, we're super honored that everybody's here. So let's get started, but not before we thank all the partners. So we have twice as much partners this year. You've seen the great booths already. It's great to have them all here, and I'd love to have a hand of applause for all of them. And a special thanks to our platinum sponsors, ST and Semtech. They're delivering a great contribution. They will deliver some awesome content as well. So thanks for them. Specifically.
And our speakers. We have the very best speakers in the whole LoRaWAN ecosystem here today. People that are working for big companies leading the LoRaWAN industry, but also the best LoRaWAN tinkerers you can find anywhere in the world that are sharing their experiences today and leading the workshops. We have more than 80 of them.
Yeah, and the visitors. We have way more visitors than last year. Now you see this, we cannot even fill the room here, that's great. Luckily there's a stream in the other hall as well. But yeah, the people that have come here, they've come from over 40 countries all around the world, literally from New Zealand to Argentina. So this is a truly global event, so great you're all here.
What do we do for climate?
Yeah, so it's 2020, so we felt that we also have to do something responsible. And if we're flying in so many people and they're booking so many hotels, the carbon footprint really starts to add up. So we decided to plant trees through an organization to compensate for all the travel by car, train, and plane, and all the hotel nights of all the visitors. So we made that contribution.
So we always start our presentations with some statistics, and it's getting more every year, and it's crazy. It's also unbelievable for us. Last year, I think on the community network, we had around 6,000 gateways. And for us, it was a lot, and also for our operations team. And we started thinking, so what if we double almost next year? How much effort is that going to be? And we almost doubled again on the community network. We have 10,500 gateways, and the rest is on our private networks. And I'm going to tell you a little bit later how we're going to connect them. Routing 9 billion messages, and we gathered a little bit more statistics for you. So look at the video. Nine billion messages in a year. What if we had a business model around messages?
Yeah,
you would be broke.
Yeah.
And we wouldn't be here, probably. No, this is the Things Network, community network, network of gateways, things, but also people. For the conference and anything you want to share, use this hashtag, the Things Conference.
Yeah.
So
let's get started.
Yeah.
Open Keynote.
So why is LoRaWAN so awesome? Why are you here? So maybe people here in the audience are new to the LoRaWAN ecosystem. So I want to share the 7 key differentiators. And Donna, I took this from you. Donna is here, CEO of the LoRa Alliance. The 7 key differentiators of LoRaWAN, things that you don't find in other technologies. LoRaWAN is really ultra low power. You can have devices sleeping most of the time, not conserving any battery. There are even demonstrations here today that show energy harvesting. There's no battery involved and still transmitting power, still transmitting with very little power. Very long range, as you saw in the video, hundreds of kilometers theoretically, and we also go to space. LoRaWAN is unique for its public and private network deployments. It supports firmware updates over the air. It supports geolocation, end-to-end security, and it has deep indoor penetration. And this makes LoRaWAN really unique comparing to other LPWAN technologies.
Yeah, so and now LoRa being almost 5 years old, that you see that the business cases are looking very positive. So if you look at our customer base, it's very interesting because we see that LoRaWAN is cracking a lot of different nuts. There's a lot of different verticals where LoRa has a play. So LoRa is everywhere. And more interesting is that LoRa is driving a positive business case everywhere. So what we have there is we have an awesome technology. We have the positive business case, but that doesn't work.
Yeah. So that's on the business side. We in TTN, it has to work. We have to route messages. That's our barrier to entry. That's our reason to be in LoRaWAN space, on top of the business models.
So we have an awesome technology that has proven to be working. Yeah. We have positive business cases. So yeah, what more do you need? Like let's scale this thing. It's working. It's making money. We only have to multiply it. So check for the technology, check for the business cases. So then if you're looking at how the market is progressing, and what we see is like the mean amount of numbers that we see that customers show interest to us is that in 2018, next slide.
Yeah.
Oh, in 2018, we had people coming and they say, I want a deployment of a few hundred. 2019, we had people saying, I want a deployment of a few thousand. And now in 2020, we see we want a deployments of a few hundred thousand. And it's not just one, it's like a lot of different fragmented solutions. So every growth phase has its challenge to scale, right? We like to talk about economies of scale, but economies of scale is a nice concept, but actually you have to work for it. So what you don't want is that if your revenue grows linearly, that your costs grow exponentially. So you're gonna always run into some scalability issues, and so actually what you want is, of course, your revenue to grow exponentially and your cost to stay linearly. But how do you do that? So that is the core of the question that we're going to try to answer in the next 45 minutes. So if we talk to customers, like for 4.5 years now, and we try to dig deeper into their requirements and to literally get into the bottom of that and go beyond it has to be the cheapest and it's all about cost. So one of the conclusions we see is that IoT is IT. So IoT is almost always part of an existing IT system. Somebody already has a meeting room planning software and just needs to have an occupancy sensor in the meeting rooms to enhance that system and enhance the efficiency and the customer experience. What we also see is that if we dive deeper into the business cases, they want manageable costs. So they want their costs to grow with the revenue, right? So they want to have manageable costs. This is a model that is adopted in the cloud already very well. With compute that you buy per cycle or per megabyte of RAM or per gigabyte of storage. IoT is always as a plug-in. We see a lot of companies that they already had made their purchase for an SAP or for Salesforce, or they already have these new low-code platforms like Mendix and ServiceNow. They want to tap into that. They want to reuse that great architecture and just extend it with a little IoT component. What we also see is that even across existing enterprises, the context can be very different. Yeah, so if I'm a large railway organization, I have trains, they move, but I also have stations, and we have buildings where my people work. So that same network needs to work in all these different contexts. Of course, security by design. That doesn't need any explanation. And we see also a lot of times the question, okay, what's the ecosystem of developers and what's the ecosystem of device makers? And of course, there's a big checkbox for LoRaWAN there.
So let us be your personal LoRaWAN solutions architect in the next hour. We're going to tell you what it takes and what the solutions are that we designed. Not only us, but most of all with our partners. Last year we said that the ones who succeed are the ones who know how to partner. And that's what we're going to show you today as well. So Laura, let's look at the anatomy of a typical LoRaWAN solution, just to give you the overview of what is needed. So LoRaWAN topology typically looks like this. There are gateways, devices send messages to gateways routed to a network server, and they send it to your application server. And at the heart of each LoRaWAN solution, there is a network server. And that is really what our key product is in. But since it is the heart of every LoRaWAN solution, it only is successful if it integrates really well with all the other components in this topology. So what we designed is the ThinkStack. This is our core product. We launched this last year at the conference. We made it open source. It took us until March until we had a first tagged release. And since a few months, we are onboarding customers on our cloud-hosted infrastructure. So it's here now. You can take it also open source, and I'm going to tell you more about it in the closing keynote today. And this is what it looks like. So we have a few components that really map well with the LoRaWAN topology that you just saw. So yeah, let's implement the smart city with this. So we built the building blocks. How do we apply this?
Yeah, so if you look into how we can build this, apply this architecture to these requirements we just saw, that what we created in this architecture is very modular, it's interchangeable, it's interoperable, and it's extendable, and you can run it anywhere. And that means that we can comply to all these different contexts that LoRaWAN is in, but also they can work together. So for instance, if you look at a smart city deployment, in a smart city you have a context of, you have a city hall that wants to know if cars are parked in the wrong place. You have a local utility company that wants to know what the water meter is saying. And you have citizens that want to measure air quality of their neighborhood to know about their surroundings. And they all can use LoRa, but how do you make sure that they can all use the same network, but they can implement these specific requirements, the specific requirements that go for security, but also for quality of service? So because we made it so modular and we separated the functions, you can play around with that. So let's look at this architecture picture. It's that you have the gateways, and you have these different actors. So I have here the Things Network, and TTI, software as a service. Government has a LoRaWAN network. The local utility company has a network. And the citizens, they want to work with the LoRaWAN network as well. So how we would implement that is that you connect the gateways to your own Things enterprise stack. So they operate with your own stack. All the network servers work together through a peering exchange and make sure that they exchange the data. So if the data from a citizen project reaches the gateway of a government installation, that gateway then forwards the data and makes sure it ends up in the applications of that citizen. And this is nothing new, right? This is how the internet works. You're just passing along messages. So the networks then are interconnected, but you saw that the gateways and the quality of service you manage there, that can be different because we have a component you see here is the gateway server. So you have different gateway quality of services you can then implement on the same network. This is not anything else than the internet. Like my Wi-Fi at my home is better than the one of the neighbors because we just have different requirements. In the end, we're using the same internet. So then a critical component in the LoRaWAN architecture is where do you decrypt the data? Because where you decrypt the data, the end-to-end encryption stops. So after that moment, you have to do that in a place that you trust. So that can be your cloud provider, that can be a software as a service solution, but maybe my local regulation or maybe my privacy officer and security officer says, no, I want this on premise and I want all the keys and all the decryption happening in something I control. Because we separated these components and separated the functions, now you can implement this decryption component on-premise, yeah, but use existing networks out there. And because everything is end-to-end encrypted, this is perfectly secure. Just like you feel secure when you go internet banking with your laptop at home using a network of a common operator.
So we built two products, actually. Our core product, the Things Stack, is open source. You find it on GitHub. Everyone with a little bit of developer experience can go to GitHub, grab the source code, compile it, and set up a private LoRaWAN network server in minutes. We have instructions for that. It's really easy, and we actually have a lot of people doing that. But then you build your own network. You have full control. We as a company, Things Industries, develops also the Things Enterprise Stack, and that is based on the Things Stack, on the open source stack. And we add some enterprise features, like enterprise single sign-on, it's multi-tenant, multi-instance, and it's fully serviced and supported. Our stack is also entirely agnostic. It runs in AWS, it runs in Google Cloud, it runs in Microsoft Azure, but it also runs in your own data center. If you have a server where you need to install this, that works as well, or it runs on premises. We also have a lot of customers, like Wienke just said, that say, hey, here's our server, we need to have our stack running here, or at least we have to have some of our core functionality running here, like the decryption of data. So yeah, that's our enterprise stack, that's our core product. Next. This is what it looks like, our console, blood, sweat, and tears in making it accessible. LoRaWAN is not easy. Doing LoRaWAN, doing it right is also not easy. So giving you insight in the deployment, in making it manageable and see what's going on, that's one of our main jobs to do, to see why is your traffic routing the way it is. Also, and this is, I'm getting super excited about this, the Things Stack is an open source project, like I just said, and it's actually a super big open source project. We are almost at 10,000 open source commits. And last year, when we open sourced it, it was already much bigger than our previous stack, but look at the statistics now. We have more than doubled our open source code base, and this makes the Things Network the 5th open source organization from the Netherlands. And that is huge. We are above Microsoft here, with all respect for Microsoft, but this is huge. So this is a huge contribution, this also to the open source community in general. So yeah, let's look at the gateways. So this is our overview. Gateways are here. One of the new protocols that are now available is LoRa Basic Station. It's developed by Semtech. And we would like to have Yun on stage from Cisco. Because Cisco is going to talk a little bit about the... microphone?
Do you have a microphone?
Get a microphone for Cisco. So Cisco...
Can somebody bring a microphone?
Cisco developed an industrial enterprise-grade IXM gateway. And in the last few years, we had very often customers that came to us and that say, OK, I have an existing Cisco infrastructure, and I would prefer to use Cisco hardware. And then there was some kind of gap with the technology that we offered. So now I'm super happy to have Yun here. So Yun, tell us a little bit about your gateway.
Okay, thanks, Wienke. Thanks, Johan. Nice to meet you guys. We haven't seen a long ride. Okay.
Thank you.
Thank you, guys. Cisco started our journey from 2015. We build hardware with our customer, and we want to offer customer total solution. But one of the importance, we find the interface between the gateway and the server is not standardized yet. So we take a lot of time trying to figure out to work with different server vendors. So very painful, very, very painful. And we're trying to work with LoRaWAN Alliance, try to define a standard interface between the gateway and the servers. The good thing is I find this requirement already in the list, in high priorities, right? That's good. So the good thing is Semtech last year, they released a called Basic Station. That is good basement. So Cisco, we are working with Semtech. We leverage the Basic Station code to build a common packet forwarder. We try to leverage that common packet forward to working with different network vendors. We want that can be an open standard basement for our interface definitions. Yeah. Right. So we are working with TTN. We are working with several other vendors. We want to offer customer an open standard diagram. Thank you.
Awesome.
Thank you very much for this
Thank you,
explanation. Jan. Thanks. So yeah, we're super happy. And we actually also got some very super happy customers because they're integrating these systems in their Cisco networks is very nice. But it's not only Cisco. So we're working with all these companies, all these gateway providers that either have it or will have it within the next half year. And this is a very good development. So again, this reduces the vendor lock-in. This removes the vendor lock-in that a gateway piece of hardware can generate to your network server. And this just services the application and network making community of customers very, very well. So let's talk about security next. So security can be complicated. And the problem is that sometimes it's being overcomplicated with all kinds of interest and reasons. And then a diffuse message reaches the market. But don't be fooled, right? Security as a business is not very hard. Ask yourself two questions. If I use IoT applications or if I use systems, I use passwords and keys. Yeah? One question, who has the keys? It seems as a very, very simple question, but I challenge you, go to your local IT architect and go to the department. So can you tell me in 5 minutes who has the keys? Yeah? I think they will have a hard time. Second question, Like everybody's talking about end-to-end encryption. Yeah, if it's end-to-end encrypted, it's fine. It's not fine, it's a tool. And it's how you use it, how safe it is. If an idiot uses it, it's not safe. If somebody competent uses it, it can be used safe. But ask yourself the question, where is the one end and the other end of the end-to-end encryption? So for instance, if you do internet banking, you see the little, you have a little key slot, and that turns yellow. And it says, the browser says, okay, says to you, I am end-to-end encrypted from my browser to the bank server. I don't know what's happened after that. I don't know. It doesn't guarantee me of what they do with my data. But that's the end-to-end encryption. That is the promise of that little icon. It's a great communication tool. But IoT is not different. The key is in the device, and the key is in the joint server. And the decryption takes place in the application server. So where is the one end and where is the other end? So how to implement this properly, Johan? Please enlighten us.
So Wienke is always asking the questions, and then I have to implement it. So how do we implement this?
When connecting a laptop or a smartphone to the internet, everyone expects to surf the internet by allowing your device to securely set up a connection with a website. A world of open standards and interconnected networks makes this seamless experience possible. Why is it that after 5 years, we still do not have this experience in the LoRaWAN IoT world? Any network should be able to set up a secure connection with any LoRaWAN device. That is why we are launching our global LoRaWAN device join server, a LoRaWAN operator-agnostic, secure device pre-provisioning platform with zero vendor lock-in, and tons of tools for device makers to help their products work on any LoRaWAN network around the world. The process is quite simple. Device makers pre-provisions new devices on their own join server or uses the Things Industry's global join server. When they sell their devices, they provide a QR code or a claim authentication code. Device owners can securely claim devices without ever seeing secret keys and select their network server instance of choice. The Things Network, the Things Industries, or any LoRaWAN network implementing the standardized interfaces. The business model is simple. Device makers pay a small upfront fee for the registration. One of our product values is at the core of our solution. Security is for security. Security should not be used for commercial lock-in, so there's no roaming or peering costs and there is no repersonalization cost. For additional security, you can use a LoRaWAN pre-provisioned secure element of choice, for instance from Microchip, ST, or Trusted Objects. And the good news is, the join server is open source as part of the Things stack. So, we highly encourage you to do the same and make sure that LoRaWAN can push the network effect of interconnected networks and make them agnostic from any network. Increasing security, simplifying LoRaWAN, and lowering the total cost of ownership. Want to know more?
So a joint server, Wienke already explained what it is for. Joint server is really the entity that you need to trust. The root keys are there. Last year at the conference, we announced the secure element solution with Microchip. And that was a really novel solution that created quite some storm in the LoRaWAN ecosystem, and I think for a very good reason. So today here we are presenting you what happened in the last year and the partnerships that we made. So we built a global joint server, and the global joint server allows for activating devices on any LoRaWAN network, running anywhere in the world on any deployment model. So it works on the Things network, community network. It works on a cloud-hosted solution that we provide commercially, but also if you use a network server that's built and operated not by us or not even using our technology, but using any of the LoRaWAN standard backend interfaces, it still works. And we build an ecosystem with all these device makers. And that is really the key thing here. This is not last year, we only had this small chip to show you. This year, we are showing you that all these device makers are onboarding their devices on our global joint server. and that they can be that they are already provisioned. There's no more sending keys by email in Excel files or printing them on stickers on the boxes. The keys are already there in a secure place. That is for pre-provisioning the keys. Then one step further is having a hardware secure module in the device where the root keys are provisioned. And the difference here is that if you have this hardware secure module in the end device, nobody can read the keys because it's physically protected against tampering. And so last year we launched a solution with Microchip, and now we are happy to announce that also ST, Trusted Objects, and Cypress are joining in this effort, and that they are building LoRaWAN pre-provisioned secure elements to the market, because we think also that diversity is really good.
Yeah, that's great. So this solution makes sure no physical exchange of keys. They're all locked in a very little safe place in the device or in a server, and never out there again.
So what does it look like? So last year was a little bit abstract. This is what it looks like. We have a €1 coin that we don't use anymore here in the Netherlands, but it's super small. It's 2 by 2 millimeters. It only adds very small space and little cost to your BOM, but it makes your device super, super secure. And it's key provisioning, you get it for free. So let's hear it from the device makers. So we built a solution, but let's invite some device makers on stage to show them, to show you how they use our solution and what it means for them to have their devices onboarded on our global joint server. So let's start with Nexelec.
Stefan. Yeah. Here. Hi, Antoine. Welcome. So tell me shortly, what do you do? What does your product do?
Yes, our product is based on air monitoring solutions like smoke alarm, temperature, humidity, carbon monoxide.
So environment,
yes,
context of a building in a room. Yeah.
Yes, exactly. So in smart building industry, dwelling managers and social landlords, we install smoke alarms and other security or air quality monitoring solutions.
Cool. Hey, and why did you select the Microchip secure element and the secure provisioning?
When we start designing this product, it was okay, but then when we sell it, our customers ask us how to get the keys. So some advanced customers ask us to implement in manufacturing a provisioning on their private key storage server. Okay. So that's good for advanced customers that know the technology, but it's custom. So it means that on our manufacturing line, we need to implement specific things to be compatible with one customer.
Yeah.
The other thing is that it's not off-the-shelf solutions.
Great. Hey, and you're not a small player, right? You're selling like hundreds of thousands of devices, right?
Sorry?
You're not a small player. You're selling hundreds of thousands of devices of your of your smoke detector and that kind of stuff.
Yes, for massive deployment, it's not easy to do custom solutions.
Perfect. So, thank you very much.
Nice.
Great.
Thank you. Thank you.
So next, Talkpool. Stefan. Hey. Thanks, welcome. Please, so to go to the center of the stage.
Thanks.
So who are you and what do you do?
So, Talkpool, we are a manufacturer of devices and also doing solutions. And we come from the telecom space, so we pretty much already from the beginning started with the same kind of secure element and trust zones that is used in cell phones, etc. So kind of natural to put it into our designs already. So the first products had this already in 2017, and now we're happy to, in the latest versions here in that produced since 2019, we have all support for it with the joint service with the Things industry.
Yeah. So you were already using a secure element, huh?
Yeah. So we had it already in all our product line in order to have secure boot, encrypted firmware, and have it super secure. So it is,
Yeah, and now we're adding it, extending it to the joint server.
Exactly, and also now we can also having this automatic provisioning that is enable scale. So security already had it, but now with the Things network, we also have the scaling capability. That's
great, that's
good.
awesome. Thank you.
Yeah, thank you.
Thank you.
Good. Hey, thank you very much. So next, we keep them coming. Fabio from Mbit. Where are you? Hey. Hello. Thanks. Hi, Fabio. Here, please go to the center stage. Yeah. So I mean, everybody that's been around from the start of LoRaWAN knows Fabio. And you're already in the market for so long, a very, very experienced module maker. So maybe can you tell them who are you and what do you do?
Yes, thank you. Good morning to everyone. So we do wireless modules. We provide micro embedded wireless devices capable to be connected to sensors. So we try to offer a solution, open platform to be able to be connected to external devices in order to deploy, to allow customer to deploy custom solution directly on the microcontroller. So we provide the SDK that can be used to develop your own application. The micro module is very small, it's very useful to implement wearable devices, and it comes from using the SAM34 from Microchip, and it allows to connect up to 17 using 17 general purpose IOs to connect devices. The interesting thing is that it's equipped with the secure element from Microchip, the 608, fully compliant with the TTN joint server. Okay. So it's very interesting to implement a secure solution.
So it has the Microchip LoRa system in a chip,
yes,
and a secure element. Yes. So you can save a lot of cost because you did the pre-integration.
Yes, absolutely. Okay. Last year we introduced this module. This year we introduced this variant that is equipped with the 608 secure element.
Okay. Awesome. Thank you very much. Super cool.
Thanks to you.
Thank you. Thank you. So this is how it works. I'll explain it. So because this is also always a question. So you buy a module. How do you prove ownership, and how do you claim that the device is yours? So the way this works is that when you buy secure elements, or when you buy a device that has a secure element inside, you get a manifest file, and this manifest is a proof of ownership. There's no key inside. It just says, hey, this serial number is mine. And you can use that manifest to claim your devices on our joint server. And when you claim the device, it's registered in your account. And you can test the device, you can manufacture the device, you can add more parameters to the device, like saying, okay, this has a secure element, but this is using LoRaWAN version 103 or 104. And then you manufacture your device, you print a QR code on it, and then the customer of the device maker can securely claim the device and use it. But there's no transfer of keys. It's just transferring the proof of ownership from one actor to the other actor, from Microchip to TTI to the device maker to the end customer. So let's look at application integration. That's the other side of our architecture. And we never wanted to build an IoT platform. We still don't want to build an IoT platform. IoT platforms are for other companies. And the reason is that there are so many IoT platforms already that it's really hard to do it right. But also, we don't want to build a silo, or we don't want to push our users into a particular direction. So we figured that the comfort zone of most of the developers is the AWS console, or the Azure console, or the Google Cloud console. That's what they are familiar with. And so our job is to do the integrations right, and to make sure that this LoRaWAN, this LPWAN technology, those green PCBs and RF and packet loss and setting up gateways, gets into the comfort zone of the average developer. So we built integrations. One of the integrations, and this is also going to be shown live on a booth here on the AWS stand, is an integration with Amazon Web Services, where Amazon Web Services is actually the application server in the architecture. So where you see here that there is an application server component that is part of our stack, it is still there, but it doesn't do the key encryption anymore. So we basically changed the end from the TTN stack to within AWS. And that means that the LoRaWAN application session key is in your AWS account, and it's not anymore anywhere in the network. And that means that we route encrypted traffic to your own AWS account that you control, where you are logged in, and you store your root keys or your session keys in the key management service of AWS. And that is really cool. But that's not the only cloud. We also have Microsoft. And I would like to have Olivier on stage.
And Icicle.
Olivier from Microsoft, one of our early adopters and big fans, and Icicle, also from Microsoft. Hey, Olivier.
Hey.
Hey, nice to have you here.
Welcome on stage.
And let's get the right logo here. Yeah?
I'm okay with that.
Yeah, okay.
So, well, thanks for inviting us, guys.
Yeah, so what, tell us, so Microsoft is investing billions in Internet of Things, in Azure IoT.
Yeah.
Where does the money go? What are you guys doing?
Half of it is my salary.
Oh, very good.
No, seriously, I mean, we understand the complexity of things. We're coming from the world of industry, and we have tons of enterprise customers, and everyone wants to do IoT for good reasons. But IoT is complex. As you just described, I love your first video up there. Yeah. Like, we see our customers stumbling at proof of concept because it's complex to implement all of that. Connect a device, secure a device, integrate the data, ingest the data, extract insights, take action, integrate in line of business application. We have a talk tomorrow. We're going to talk with Icicle about all these various steps where we offer simplification. We have some solutions like IoT Central. We have a bunch of other services that are building blocks for you to create your own solution. We have options for our customers depending on which industries they're working on and what they want to do to implement their solutions on Azure in other clouds as well with our bridging of various clouds with Azure Arc, and we allow our customers to build what they want. And integrations with partners like the Things Industries and Things Network are key for us. Customers, we don't want to be in the business of creating all what you described to securely connect the devices. They also don't want to be in the business of managing a set of workloads in the cloud. They want to have a turnkey solution for them to get started fast. And Icicle, I'm going to let her a little bit talk about how we are also simplifying what's the rendering, the data in context with things like this very cool device here.
So what is this? Can you put it on, Olivier? Just and then you. What is this?
So this is the new HoloLens device, HoloLens 2, recently released to the market, and it's the augmented reality, mixed reality device, where a worker can work on a device or anywhere and can see the related information right in front of them and not lose the contact with what they're doing. So it's totally transparent, and as you can see, you can take it off or put it on a headset. And we have a bunch of services that helps you visualize IoT data.
Yeah, because that's the thing, it's a visualization. So, so how does this work? Olivier, are we, if you have this HoloLens on, what does that mean for device provisioning, or what is the relationship with LoRaWAN?
So what you need to understand about this little guy here is that it's a full machine, right? This one doesn't need to be connected to do anything. It's better if it's connected, but it runs all the intelligence of getting you the data in context. So scenarios such as you walk through a factory floor and you see the telemetry data of the devices that are around you is exactly what we are achieving thanks to the HoloLens technology. So think of that scenario of the operator setting up a new LoRa device. He wants to claim that device. You can just have this little thing. You saw how I was able actually to use it as a cap and then as a visualizer. You can bring it down. You can scan a QR code and immediately in your environment say, I'm going to set it up on that wall here. And suddenly you're going to see the real-time data of that sensor appear on that wall each time you walk by this thing.
Exactly.
And it extends beyond the HoloLens. The HoloLens is one of the devices. The technology itself has your data stored on Azure, available through APIs that then you can grab an Android device or a iOS device, put it in front of that very wall, and see the same data in the same context, depending on who the operator is.
Very cool. And I think we have a video about this, right?
No, we don't.
No, we don't?
You can experience it.
Okay.
They at their booth.
Thanks.
And yeah, super excited about it. I really like the fact that this is not just a gadget. It has a very serious ROI from the day you buy it. So I think this is super cool in the IoT sphere. So thanks for being here.
Thank you so much. Thank you. So connecting networks. So we've been covering a few parts of the stack on the gateway side, device maker side, application server side. But let's talk about connecting the networks. And this is actually one of my favorite topics, and I've been talking about this in the last 2 years on all the TTN conferences. But now we can actually finally launch the packet broker. So why would you exchange traffic? That's I think the most important thing to start with is why would you do it in the first place? And first of all, of course, better indoor and outdoor coverage. The more gateways, the gateways are seeing the traffic already. So why not have those networks route the traffic to you? Why not? It's shared spectrum. The air and the time is as free as it is for your competitors, or for your partners, or for your neighbors. Second is better resilience against gateway failures. Gateways are powered. They need to have an internet connection. Things go wrong. More gateways is always better for that reason. It also increases the network capacity and longer battery life. Now, Wienke has 2 little children, and Wienke is really good at drawing. So this is one of Wienke's latest drawings, and it shows an unhappy gateway and a happy gateway. So you see on the left the sensor, and the sensor needs to reach the gateway that you see here on the right, and it's super far away. And it means that it has to communicate with a high transmission power and a very low data rate, so it takes a lot of time. It costs a lot of energy. And in the meantime, this other gateway from somebody else sees this message as well, and is also demodulating it, processing it, sending it to the home network, and this home network says, oh yeah, sorry, it's not for me, and throws it away. And that's what happens today. So the key thing here, and this is how it relates to longer battery life, is to have these networks connected, and to make sure that other gateways, closer gateways to your devices, that receive your message already, route it to the home network and route it to you, so that the device can increase the data rates and lower the transmission power, and that saves battery life. And saving battery life, decreasing the battery consumption, and increasing battery life maybe from 3 to 4 to 5 years, that is a game changer in the total cost of ownership of large deployments.
So this is directly where you have the business model of network sharing, because your own deployment is going to be cheaper by sharing the overcapacity of your network. TTN is so successful because there is no transaction model of exchanging network operator value, because the value is already in the exchange itself. There's true synergy in connecting LoRaWAN networks.
Yeah. So that is the why. Then we go to the how. How do we do this? And what did we build?
We think it is completely normal when you connect your phone or laptop to Wi-Fi, you have direct access to the whole internet. This should not be any different for LoRaWAN, where you'd be able to connect your device to any network. But until today, there has been limited WAN and LoRaWAN. Today, we have a world of LoRaWAN networks separated by glass walls. We need to tear down these walls. On the internet, it is completely normal to forward packets to the right destination regardless of who owns the network. And in the LoRaWAN ecosystem, we have an additional benefit because network collaboration highly increases the network capacity spectrum usage and device battery efficiency. More gateways closer to end devices is always better. For resilience against gateway failure, reduced channel utilization, reduced transmission time, and ultimately, increased battery life. And LoRaWAN allows this to be done completely secure because of end-to-end encryption. There should be an easy way to make any device work on any network and route the data to the home network, wherever that is and whoever operates it, including you. To support this, we launched the Packet Broker, a network-agnostic global LoRaWAN traffic exchange that supports the latest LoRaWAN standards. The way it works is simple. You subscribe to the packets of your network and you publish the packets your gateway receives from other networks. The business model is clear. Participants pay a fair subscription fee to be a part of the exchange. When using the optional paid peering marketplace, there's a small commission on the transaction. The packet broker launches with more than 25M LoRaWAN packets being routed every day, with traffic from more than 30 operators and private networks. Ask your operator today if they are part of the packet broker.
So the packet broker is the global backbone for LoRaWAN traffic. It supports uplink, downlink in class A and C, and even device activations. It has an open source API. It's already available on GitHub. And it's available as a hosted solution. So we operate it just like the Things network, but it's also available as a product on premises, because we also have users and customers that have their own private networks that they need to interconnect together. And you can do both. You can have your own packet broker, and you can use a hosted collaborative packet broker in the cloud. So what are the key features? I'm going to talk about this more later today, but most important things are its individual packet selection. So it's not that you have to pay for each and every packet that you receive, but you can select which packet you want. We separate the traffic routing from the billing. So the routing is all encrypted, and how you get the decryption keys is up to you. You can have any out-of-band agreement. You can send somebody else an invoice, and you can share your encryption key. But we also support collaborative marketplaces, where you have one billing relationship with the marketplace. You contribute traffic, you consume traffic, and the only thing you pay is the offset. We also separate payload from metadata. And this is key because sometimes you already received the payload, and you don't have to pay for the payload again, but you want to receive the metadata, for example, to do better geolocation or to have more downlink capacity available, or the other way around. And finally, you don't need to operate a LoRaWAN network, because we also separate the forwarder role, so the members that are operating and owning gateway infrastructure, from the members that are operating home networks. You can be both. You can have gateways and a home network, but you can also have a gateway-only approach. So tower companies, for example, that only have towers, they are not interested in running LoRaWAN networks. They can join the packet broker. They can install gateways. They can have these gateways route the traffic directly to the packet broker, and they make money by selling traffic. So that is unique to the packet broker. So what's next?
Yeah, so we've touched a lot of subjects already. And we did a very, very interesting project last year in the maritime industry. And therefore, we used 2.4 gigahertz LoRa.
But what is the problem with LoRa today? What is the key challenge if you ask device makers?
The key challenge there is that, of course, we have this local sub-gigahertz bands. And you have to have an SKU for every continent or every segment. So 2.4 gigahertz, we all know it from Bluetooth and Wi-Fi. And there's actually also 2.4 gigahertz LoRa. And we're starting up projects in that section. And I want to ask on stage the first partners, the Semtech and Multitech. So Stale and Stefan, please join us on stage.
Hey, Stale.
Hey, welcome. Here you go.
Hey, welcome. Yes.
Great. Hey, welcome. So can you introduce yourself shortly?
Sorry?
Can you introduce yourself shortly?
Yeah, my name is Ståle Pettersen. I work for Semtech, been part of LoRa from day one, I think. First chairman.
Hi, good morning, everyone. I'm Stefan Lindvall. I'm the CEO of Multitech. Very, very happy and pleased to be here. Thank you for the invite.
Yeah. So thank you very much. So what do you have in your hands? What is this?
You mean that I should tell the world what this is?
Yeah. I'm very curious.
Yeah. So I think informally, this is the pre-announcement of the first working 2.4 gigahertz LoRa gateway. Exciting stuff. It's working. It's running. We have it demoed today, tomorrow, and super happy to be here and present it together with our great partners from TTI and from Semtech.
Yeah.
So Stale, what is LoRa 2.4 gigahertz? What is it?
2.4 gigahertz. It is basically LoRa modulation. Yep. We have looked at the use cases for LoRa and looked at the challenges in 2.4. So location is important, wider bandwidths to allow more accuracy for location application, but also to get more resilience to interference from Wi-Fi, Bluetooth, and other solutions.
They are also in 2.4, right?
So on 2.4.
Yeah.
So it also allows you to go up to higher data rates, reducing the cost of the sensor because the battery is one of the critical elements to save power in track and trace applications.
So it's one global SKU for the whole world?
Yeah, that is one of the trade-offs that we have done.
Yeah.
Because we don't want to have many SKUs, so we have ensured that we have output power that allow us to have one frequency setting for every single country.
Okay, so you do your certification once, everything is super easy, but that almost sounds too good to be true. So what is the compromise? Is it?
So one of the things you see a lot of marketing, I can say you can have kilometers of range and it will be great, like we have a use case in Ireland where we have a 7-kilometer range. But in reality, you have penetration loss, you have weather condition. So in urban environment and in buildings, you will experience tremendously lower range than traditional LoRa sub-gig. So 1/10 of the distance in a building.
Okay. It's in.
Cool.
I think we have a very good use case where it fits perfectly, right? We're
Yeah,
going to show
yeah,
that right
yeah.
now. Yeah. So first of all, the partners. So we have Multitech here, building gateways. We are involved on the network side. We have device makers. So this is really the first partners who are starting with, but everyone can join this, right? Everyone who wants to get started with 2.4 gigahertz can start today.
Everything is ready. Multitech, you can cover gateways. We have also development kits, partial been out there for a while, so it's good to go.
Awesome.
Super cool.
Cool.
Great. So, Stale, please stay. Thanks for being here. We want to ask one of our customers.
Thank you, man.
Williamson, John, on stage. So,
Hey, John.
welcome, John.
Welcome.
Hi. Hey, welcome. So, can you tell us something about yourself? So you used to be a captain of one of these
It's
ships.
the wrong color.
Okay.
It's green and gray now.
Okay, it's in green right now. Okay, that's good. So what do you do? I mean, some people don't know what Williamson does. Can you tell us shortly what do you do and what does your company do?
I work for Wilhelmsen. We are partly owner of Wallenius Wilhelmsen. We have 140 ships like this, sailing all over the world. And we have been looking for, when you buy a ship, you go for the cheapest one because you don't want to spend a lot of money in technology and stuff.
And what is cheap in this?
Maybe $100 million.
Okay. Let's.
So until October last year, I was partly a vessel manager for 2 of those ships, and I also work with technology in Wilhelmsen. And about 2 years ago, I learned about LoRa, and now I'm a big fan.
Perfect.
Great.
That's great. Thank you very much.
Yeah.
So
tell us a little
maybe
bit
one
more.
question.
Yeah.
Can you explain one of the business cases that we're implementing? Just to.
I think LoRa is an enabler because in the recent year we want to collect data to operate the ships in a more efficient way. But as you talked about the verticals, we have a lot of verticals on board the ships. There's a lot of systems which is not talking together. And we want to use LoRa as the enabler to collect these data. Yeah. And also to monitor machinery to work more smarter and save money and do better business.
So if there's any device makers or systems integrators that are interested to build solutions for you, then they know how to find you, right?
Yes. And this is the first 2.4 sensor for condition monitoring.
Wow.
Nice.
It's running, 5 of these are actually working on a ship sailing worldwide now.
Yeah. But you're open to any other partner that wants to build this, right? It's an open platform.
Yes.
Awesome. Great. Thank you very much.
Thanks. 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 LoRa on ships, it's really cool. So what does it look like? Gateways are running on the ship. And you imagine that these ships are going all around the world, right? So they go from Europe to China, and they, because it's one frequency band, they don't have to know where they are and switch the bands and have a really hard time with any certification and testing. Instead, they just keep on communicating. The gateways are on the ships, so all the goods in the ships can communicate to the network, and that allows the customers of Wilhelmsen, for example, to transport goods and to track them through the Wilhelmsen network that is on the ship. And when these ships sail on the ocean, they have a satellite backhaul, so still information can go to ground stations. But when they arrive in the terminal, there is also coverage with 2.4 gigahertz LoRa. So that's really cool. Global coverage. We are even going more global than that. So let's have Thomas here on stage from Lacuna.
From Lacuna Space.
Hey.
So, yes, now things start to get really excited. I mean, you've been around with us in the Things conference. So the main attraction for 3 editions already. So maybe for people that don't know you, can you tell me who are you and what do you do?
So I'm from Lacuna Space. We do something with satellites, and last year I was here as well on stage talking about satellites. Today, this morning, I'm receiving messages, standard LoRaWAN messages from a sailing boat, which is literally in the middle of the Atlantic Ocean. When the sailing boat is in the harbor, we see the messages over TTN. When it's on the sea, we see it via the satellite. So it's working, it's exceeding our expectations, and I'm personally astonished with every message I see coming in at the moment.
Wow.
So there's a satellite up there.
There's one up there.
There's a sensor sending a message, but when it's near a TTN or Things Industries gateway, then it's being routed and takes the most efficient course, and it saves the satellite.
Yes, the both can talk both to the gateways on the ground as well as to the satellite.
So when you receive a message on the satellite, you send it to a ground station, and what happens then?
It's sent to the ground station, and then we're now connected to the packet broker.
Okay.
There we go.
Yeah.
That's what you wanted to hear.
Yeah, that's what I wanted to hear.
We send it to the packet broker. The packet broker routes it to the owner of the network, and it's being delivered that way.
Awesome.
Yeah.
What do we see here?
So we have working together very hard on integration, and what we have working here today at the conference is a device with a secure element with pre-provisioned keys that makes a join to the Things Industries join server. With those keys, it can send to the satellite. The satellite receives the message, sends it to the ground station, that sends it to the packet broker. The packet broker brings it to a private network, cloud hosted by the Things Industries, and from there we send it to Slack. So all the cool things you have been describing here, we have together in one cycle, in one demo, operational.
Yeah.
Wow.
Now, I mean, we've been working together for so long. And one thing I'm super excited about that what we're going to do in the next year is to make sure that paying for your service, because sending a satellite up to space is not cheap. It's going to be run through an MVNO, like a LoRa MVNO, and we're going to leverage our existing billing channels. So we have credit card invoice, but also billing through your AWS account directly. So, like at the end of this year, getting satellite connectivity will literally be at the push of a button and a swipe of your card.
All this integration we have done, you don't have to do. So by the end of the year, you will indeed, if you have a cloud-hosted private instance, you will press a button, it will enable the satellite connectivity, and you will receive your billing all over the same channels as you already get your...
Super cool.
Awesome.
So this sounds too good to be true. But like, is there any compromise? Like, is the device different, or like it almost sounds unbelievable?
It's a standard LoRaWAN device, and that's really important. So we see satellite as a fundamental part of the LoRaWAN ecosystem. So all the things you hear and see here on the floor are applicable to the satellite as well. The only difference is the antenna. Come to see
the
us.
Antenna, yeah.
The antenna is different. There's also a talk from Fabian Ferreira who will explain more about the antennas. But other than that, it's a standard LoRaWAN device with a standard LoRaWAN stack on it.
Cool. Thank you very much.
Super cool.
Thank you.
Hey.
Thanks. Thanks.
So, device makers. So if you ask a VC, what should I, and I'm in IoT, and you ask the VC, what should I do with my money? They say, go build a platform and stay away from hardware as much as possible. So in the market, all the easy, lazy money goes to platforms, which we already have enough of, and hardware people, they're always under-supported. And I think we as the Things Network have also lacked in that sense, that we could have been way more supportive with open source code and community content towards device makers. So we have now 3 great companies, and they're all going to tell us what they're going to do. And the first one is going to be ST, because there was some very cool announcement this year.
Benjamin.
Yes.
Welcome, man.
Welcome.
Hi, everyone.
Thanks. So, it's on.
It's working?
Yeah.
Hi,
So who are you?
So I'm Benjamin from ST Microelectronics, in charge of unlicensed LP1 activities in microcontrollers division.
Cool.
Yes. And we're super excited to be here presenting this beautiful product. So this is actually the first system on chip in the world, which is LoRa enabled. So system on chip means that actually everything is embedded on the same silicon die. I mean the microcontroller part and the LoRa capability on the same silicon die, okay? So it's actually, I would say, kind of a breakthrough because it's a major new LoRaWAN enabler, okay? And most probably the main point that I could highlight right now are the following ones. First of all, the deep integration coming from the fact that it's a system on chip, right? Then it's multi-modulation capable, as you can see on the screen, right? So that means that you guys, device makers, will have the ability to implement whatever other protocols or proprietary protocols or applicative layers on top of your LoRaWAN stack. Also, it's provided as an open platform, so that means that you guys, device makers, will always have the flexibility to implement whatever you want into it. So very important point as well. And last but not least, it's based on the best-in-class ultra-low power platform STM32L4. So that means that, of course, we all know that battery lifetime is of paramount importance for LP1 use cases. So it's based on ultra-low power L4, so everything should be okay in that framework as well.
Cool. So yeah, you can build LoRaWAN devices, you can LoRa devices. So it's a very generic RF. I see all kinds of other technologies. So that brings a lot of, like, it's a very agnostic product that gives a lot of opportunities.
Yes.
It's super interesting. So,
yes.
Yeah. Cool. Thank you very much.
You're welcome.
Yeah.
Thank you.
And, see you at 12 o'clock for the keynote, right?
All right. He will be on stage telling all about it. So, who's next? Samir from Murata. Where are you? Ah, here he is. Welcome. Thanks.
Hey, Samir. Hey, welcome.
Great. Another LoRa veteran, right? Oh, people from the first day. So tell us, like, who are you? What do you do?
Yeah, so I'm Samir from Murata. We're working actually for a while with these guys. I think it's more than a couple of years so far. So we are a Japanese company making modules. We are coming from the Wi-Fi Bluetooth business. So if you come to our stand, you will see that we are producing very tiny modules. And one of the things that Wienke was stating is some of people don't want to stick on hardwares. They want to go directly to the point. And basically, our product is a kind of open platforms. Just before, was talking about the ST product, and basically we are embedding their stuffs inside as well. And one of the 2 points that I noticed from what you two guys explained today is they have 2 main points which has to be solved in order to break through such kind of emerging technology. First one is scalability. And Murata, basically, we are producing 400 million modules per year. So in terms of scalability and production, we know how to do. And the second part is the security. And when we were talking 2 years ago, we were like, how can we come together to the market? And the security so far was not a kind of mainstream we have to discuss about. But from now on, from what you can see in the news with the IoT, with the problems you can have so far, this is something that Murata was considering seriously. So that's why we're talking with people like with Trusted Object. We're talking also with Microchip, with ST Micro, in order to put robustness and much more liability to the product. And I think this is what LoRa is now needed to do on. So as you can see now, this module is extremely tiny. So today we are launching this one. This is 8 by 1 millimeter. So it's even, I can even not say, just go to the wall of fame, you will see how tiny it is. It can go to even a small watch. So we are very proud of it and also continuing working with this very talented guy. So thank you.
Super cool.
Thank you very much.
Thank you. Thank you.
So next is Nicolas Sonnen, the man himself.
Ah, Nicolas.
Co-founder and co-inventor of LoRa. Give him a big hand of applause. Hey, how are you? You have something in your mouth.
Thank you.
Were you eating ice cream or no? The coffee, sugar in the coffee. Very good.
Sugar, I need sugar.
Yeah. Okay.
So for the people that have been lying under a stone, who are you?
So I'm Nicolas, one of the inventors of the LoRa technology, and currently I'm the CTO of Semtech.
Wow, great.
Oh. So what is
tell us
yeah.
about so what do you do to make the lives of device makers better, less risky, less costly? What do you do?
So last year here at the conference, I presented the concept of a modem, or LoRaWAN modem, that would come with all the missing pieces, the best security practices, the provisioning services, all of that. So that is now actually becoming a reality. We've worked hard with Murata to provide best-in-class drop-in LoRaWAN modem. But we also took the decision to actually transform that into an open source code, so you can actually run it on absolutely any platform. So very soon, we'll be introducing the South modem, or basic modem, which is our brand new open source code. It includes not only the LoRaWAN stack, but a bunch of services on top to actually ease the life of the application developer. So for example, we'll provide optimized fragmentation service, so you don't have to care about the length of the payload, whichever data rate you're using. We'll provide a tool to generate keys using the best security practices. We'll provide connection to an external secure element if you want to use an external secure element, as you described before. And all that come actually wrapped with the associated services. Wow. So if you have an encoder on the device, you need the decoder that goes with the cloud. So all of this will be bundled into a cloud service API that you can use.
Yeah. Cool. And so these all kinds of services to make it easier to adopt LoRaWAN. But what really excites us is that it's open source. It's going to be open source, right?
Exactly.
Okay,
this is going to be open source, and it's coming really soon.
Yeah. So I don't have to marry you to use it. I can just use it myself as well.
Exactly. So you're not tied. Exactly. You're not tied to Semtech. So if you want to use Semtech joint server, you're more than welcome to do so. But if you want to use TTI joint server, that will be perfectly possible. You'll not be tied to Semtech in any way.
That's right in our alley. Thank you very much. This is awesome news.
Thank you. Thank you.
Succeed.
Thank you.
So we must be almost there, right?
We are done.
We're done. Okay. So thank you very much for your attention. It's going to be a great show. We're going to have Tesla coils generating lightning to see if LoRa message can stand that. We have great workshops, great booths.
We have an ice bar experience?
We have an ice bar experience. It says hot chocolate, but there's a bit more if you ask kindly to the barman. Enjoy this awesome conference. There's so much content. Luckily, everything will be online. We want to thank you very much again for being here. Thank all the partners, and see you around.